Hello students, today we'll start electrochemical cell. So we learned in introduction part two types of electrochemical changes. What are those? One is electrochemical cell and electrolytic cell. Electrochemical cell and electrolytic cell. In electrolytic cell, in this case, redox reactions are spontaneous and chemical energy is converted into electrical energy, that is in electrochemical cell. And in electrolytic cell, this redox reaction is non-spontaneous. Here electrical energy is converted into chemical energy. This is electrolytic cell. In this electrolytic cell, energy providing from outside for occurring redox reaction. Okay, energy is providing from the outside. So over here, a device which redox reaction are spontaneous and chemical energy is converted into electrical energy is called what? Electrochemical cell. And device which redox reactions are non-spontaneous and electrical energy is converted into chemical energy, that is called electrolytic cell. Or we can say passage of electricity is required to bring about redox reaction is called electrolytic cells. So today we will discuss only one type of cell, that is electrochemical cell. So when we talking of electrochemical cell is a common type of cell and it is first developed cell. Okay, that was known as Daniell cell or galvanic cell. Once again I will repeat, electrochemical cell is a common type of cell and it is first developed cell that was known as Daniell cell or galvanic cell. Daniell cell or galvanic cell. So when we talking of electrochemical cell, there are two half cells which are present. Okay, in one half cell oxidation reaction taking place and that is called oxidation half reaction, and another half cell reduction reaction taking place, that is called reduction of cell. In electrochemical cell there are two circuit. One is external circuit and that is connected with the help of key, that is ammeter or galvanometer, and other one is internal circuit that is called salt bridge. Okay, let's see what is an electrochemical cell. It is a very simple kind of apparatus which is set up. We'll take two glass beakers. In left hand, galvanic cell and a galvanic cell beaker. So here we are taking 1 ZnSO4, that is zinc sulfate, and in second one we'll take 1 copper sulfate, CuSO4. So we are taking two simple beakers. Left hand, that is ZnSO4, right hand side we are putting CuSO4. Over here we are dipping electrode. Here we are dipping electrode, which electrolyte we are taken, no, that electrode only we have to dip. So here we are taking ZnSO4 electrolyte. So here in this beaker we have to put electrode, that is zinc electrode. Okay, here we are taking ZnSO4 electrode, so it is a electrolyte. So we are dipping Zn electrode. Same way here also in CuSO4 solution, this is an electrolyte. Here we are taking copper electrode. This is a electrolyte. So same electrode we have to dip in this beaker. This is a setup. Here we are taking ZnSO4 electrolyte. So here electrode are made up of zinc, and similarly we are dipping electrode copper electrolyte. So electrode is also made up, should be copper. Okay, now we are connecting it to a key. This is a key. It may be a galvanometer or ammeter. Okay, and we complete the external circuit with the help of wire. Okay, internal circuit by placing inverted U-tube. This is a inverted U-tube. This U-tube mouth is closed by an agar-agar solution or jelly. This is inverted U-tube. We commonly call it as a salt bridge. This is an internal circuit. So this mouth is closed by agar-agar solution or jelly. So purpose of closing is due to whether electrolyte we are filling in this U-tube, that electrolyte is not directly contact with this outer electrode. Okay, whatever the electrolyte is filling in this salt bridge, that electrolyte is not directly contact with this outer electrolyte. Okay, here CuSO4 electrolyte, zinc electrolyte we are taken, no, that electrolyte is not directly mixed with or contact with this internal electrolyte, that what we taken in the salt bridge. So that's why you have to close this mouth. This is the inverted U-tube. So in salt bridge, this commonly called it as a salt bridge. In salt bridge, U-tube, you can say U-tube, taking an electrolyte is, here we are taking some electrolyte, that is that is KCl or KNO3 or NH4NO3. These electrolyte we have to take in this U-tube is taken in the form of semi-liquid state. I am repeating, semi-liquid state. Why we are taking semi-liquid state is due to why, because we are taken it as an inverted U-tube, no, it doesn't flow through this mouth. So if we take it in the form of liquid state, it will flow through this mouth, okay, and it connected to outer electrode. So that to avoid that, we have to take it in the form of semi-liquid state. Okay, left hand side, this is left hand side and this is on the right hand side. This left hand cell is known as a anode. So this anode is negatively signed and right hand side is called cathode. This is cathode, is signed, positively signed. So this is a electrochemical cell setup. So remember, here in electrochemical cell, always in left hand side, that is anode present, that is negatively charged, and on right hand side cathode present, that is positively charged. This is a setup of electrochemical cell. I am repeating that left hand side, this is anode is negatively charged, and right hand side, that's it cathode, that is positively charged. Okay, this is a electrochemical cell setup. So first point you should note it in electrochemical cell, that is in electrochemical cell anode is negatively charged and cathode is positively charged. That is the first point, and anode is placed at the left hand side and cathode is placed at the right hand side. It is the second point. And third point, in anode always oxidation is taking place and cathode reduction taking place. What do you mean by oxidation? Oxidation is a loss of electron. Cathode means this is a reduction. Reduction means gain of electron. Remember, anode, oil means oxidation in loss of electron. Cathode means reduction in gain of electron. Have you remember oil and rig method? So always in anode oxidation is taking place and always in cathode reduction is taking place. Always in oxidation taking place means loss of electron and reduction taking place means gain of electron. So in this anode oxidation is taking place. What happens oxidation here? This zinc metal, that is have tendency to lose electron, that lose the 2 electron, means this Zn metal will lose 2 electron and forms what? Zn2 plus. Here what happens in oxidation reaction, this Zn metal will lose 2 electron and that start going to convert it into Zn2 plus. This Zn2 plus start accumulating inside this solution. This is undergo aqueous solution. Okay, this is anode part. And in cathode what happens here, already here Cu2 plus ions are present in the aqueous solution. Here in aqueous solution Cu2 plus ions are present. It gains what? It gains 2 electron. So whatever the electron will passing here, and 2 electron will gain this Cu2 plus and forms, it get converted into Cu. This is going to convert into Cu. Here Cu2 plus ion whatever in present in aqueous solution, that gains the 2 electron and converted into copper. This is known as what? Reduction half cell, and this is what? Oxidation half cell. Always in anode oxidation taking place, so this is oxidation half cell, and this is cathode reduction taking place. This is reduction half cell. This is the complete electrochemical cell setup. So here what are the observation we are seeing in this cell? Let us see. First observation which are going to see over here, that is first observation, that is zinc electrodes start losing weight. So why it's saying zinc electrodes start losing weight? So you have seen in this reaction here, Zn is losing 2 electron, is converted into Zn2 plus. What happens? This electrode will become reduces here. It converted into like this. It dissolved. Okay, slowly this Zn electrode start losing the weight. Okay, so that's why Zn electrodes start losing the weight. First observation we are seeing here. And second observation, what? Copper electrode gains weight. Copper electrode gains weight. Why? Yes, Cu2 plus electron is it gaining 2 electrons and converted into copper. So that copper will be accumulating here on the electrode and it gains the weight. So this copper electrode gains the weight. And first observation, this zinc electrode will loses the weight because this electron will remove from this zinc and converted into Zn2 plus ion. Here Zn2 plus ion will be formed. This Zn will converted into Zn2 plus, that's why losing the weight. And here copper 2 plus ion gaining the 2 electrons and converted into copper, so that's why it gaining the weight. These are the two observation. And third observation, so third observation, what is that? Electrons flow from anode to cathode. Here Zn will losing the electron, these electron will flowing from anode to cathode. Isn't it? Anode to cathode, the electron will be moving. If the electron flowing from anode to cathode, you know that current will be flowing opposite direction. Is it correct? When electron flowing in one direction, the opposite direction will be current will be flowing. Isn't it? Okay, so current will start flowing opposite direction. The opposite direction means what? Cathode to anode. You will see deflection in this galvanic cell. So that is the fourth observation. Fourth observation is what? Current will flow from cathode to anode. So current will start flowing from cathode to anode. So this is current. So when electron will moving from anode to cathode, so same simultaneously current will flowing opposite direction, that is cathode to anode direction. So on that time this ammeter or galvanometer deflection will shows like this. So that we understood that current will flowing in opposite direction. So this is the 4 observation in the electrochemical cell here observing. So these are the 4 observation in electrochemical cell. So what happens here? Concentration of Zn2 plus ion increases in the anode, increases in the anode solution, and here concentration of copper 2 plus ion decreases in this beaker, that is cathode part. this here Cu2 plus ion concentration decreases, here Zn2 plus ion concentration increases. So why Cu2 plus ion decreases? Because Cu2 plus ion gains gain 2 electron and become copper, become Cu state. So concentration of Cu plus ion decreases here in this beaker, and Zn2 plus ion concentration increases in this left hand side beaker. This is what your electrochemical cell is going to be. Okay, right. Okay, remember that in electrochemical cell, anode is negatively charged and cathode is positively charged. So reduction will takes place at cathode and oxidation will take place at the anode. Always in electrochemical cell, reduction will taking at cathode side and oxidation will taking place at anode side. So the question will come from this part, what is the significance of this salt bridge? So that will discuss in next section. Thank you.